Welcome to the channel again. So this is the second video on naivebayes, and this is called the multinomial naivebayes, which is an effective method, supervised learning method for text classification task. So in this example, I will perform a sentiment analysis using financial sentiment dataset. The dataset is available in the repository. You can download it. So let's get started. So let's import the required libraries. So import pandas SPD, import matplotlib.pyplot, splt, then from Scikit-Learn preprocessing, import label order, encoder from Scikit-Learn.pipeline, import pipeline, model selection, import train test split, import count categorizer, from Scikit-Learn.naivebayes, import multinomial naivebayes, and finally from Scikit-Learn import matrix. So these are my required libraries. Then load financial sentiment dataset. dd.read.csv. So this is our dataset. So this is basically headline, news headline. This is one column, and this is basically sentiment of the public after reading these headlines. So there are three categories: neutral, negative, positive. Let's check the shape. So it has 4,846 rows and 2 columns, which is sentiment and news headline. And we can see already that there are 3 unique types of sentiments. Let's print. So neutral, negative, positive. And also check the fellows. So there are 2,879 neutral sentiments, 1,363 positive sentiments, and 604 negative sentiments. Let's plot them as a bar chart. So plot kind will be bar. 0 color, let's say RGB, 𝑘.xLabel sentiment. Subjective. This will count 𝑦Label 𝑥text Okay, so you can see that neutral is 2879 neutral sentiments, and then positive 1363, and finally negative 604. So let's apply pre so label encoder sentiment. So I will convert these like text sentiments into numbers. Let's check. So now we have 102 instead of neutral, negative, and positive. Okay, so now let's separate features and labels. We only have the news headlines as our features. So tf dot target. Then split the data set strain xtest ytrain ytest train test display x to y Okay, let's check the length. So we have 3876 data in the train set and 970 in the test set. Now we need to apply factorization and multinomial naivebayes. CLF pipeline. First we'll provide the count factorizer, followed by our classifier, which is multinomial naivebayes. So the count factorizer will basically convert these words into tokens in a factorized representation, so that we can fit them to our model. Then self.fit. Okay, let's check the accuracy on the test set. Round self.score, xtest, 𝑦Test. Okay, it's 75.57%, not very high. Okay, now let's plot confusion matrix. 𝑦Predict will be self.predict, xtest, then disp.plot, CMap, color bar, font size 15, font weight bold, this will be 𝑦𝐿𝐴𝐵LE, font width, title, this is 𝑦Tix. Okay, so not a very good looking confusion matrix because our accuracy is not very high. So this is probably the best case scenario, where we got 518 correct predictions compared to 53 wrong predictions. But here we have 60 correct and 50 wrong. Here we have 155 correct but 134 wrong. So that's not a very good outcome. Let's copy this and represent this classes 0 and 2 with categorical labels. So 0, 1, 2, 0. So 1 means neutral, 0 means negative, 2 means positive. So our serial will be negative, neutral, positive. Okay, so it makes sense. Let's print F1 score. So F1 score is 75.57%. Same as accuracy. Okay. Then after that, print classification report. So we got some bad values. So from the configuration matrix, we can see that this is kind of okay, but this one is bad. This one is also bad. So we got these very poor values here and here as well, but this one looks better than compared to other two. Let's do a random prediction. So this is our X test set. Let's select this one. In 38. Okay, it says in Finland the corresponding service is Alma Media's 𝑦𝗏𝗏𝑒.com, Finland's most popular and best known nationwide online service for home and property sales. Okay, let's check its class 1. So I think 1 is 0, 1, 2. So 1 is I think neutral. So this is neutral. But I want to now made up something. So I'll make a sentence. So in France, instead of in France, the company, so this is company 𝘗𝗏𝗏. I don't know what is this 𝘗𝗏𝗏. Is the best Breweries, and it is located in Bordeaux or something. Pronunciation is probably Bordeaux. So let's pass this thing. Okay, so it gives array 1, which is also neutral. We actually do not have a way to determine whether this is actually correct prediction or wrong prediction, because I made this sentence up. But for this one, I can check individually. So let's 38. Okay, so this is quite similar, but a smaller sequence to this one. Both says it's neutral, and the ground truth level is also neutral. Okay, so this is just a random prediction. Now, so we actually have 3 types of sentiments: neutral, negative, and positive. And neutral doesn't mean actually it's neither positive nor negative. But if you look at this sentence, it's appreciating, like the corresponding service is Alma Media's 𝑣𝗏𝑡𝑉.com blah blah blah. Most people are best known service, home, property, whatever. So it looks like it's appreciating. It could have been positive, but in this case it's neutral. Let's make the dataset a little bit simpler data frame. df.sentiment not equal neutral. So sim.df.head. So I have dropped all the data that has a sentiment of neutral. Let's check the shape now. 1967. So we had like how many? 2879. So 1967 plus 2879. 4846. That's how many data we had when we used all the sentiments. But now I have dropped this part just to see if our model can predict better. So I will just copy some part. I will not plot this metrics and everything, just have to use this line. Then I want to use this line. So Ctrl+X, Ctrl+V. Just changing the name a little bit. Putting underscore here. This will also be changed. So this will now sim.df dot new subline, which is the features, and sim.df dot sentiment. let's run this part. So now we have 1573 in the train set and 394 in the test set, and the samples are this size. So now just copy which line, this line, and just copy this part. Oh, sorry, we have to scroll underscore here. Okay, now we can see the accuracy increased by 10%. Now it's 85.7 compared to 75.6. So when we dropped the neutral part from the sentiment, the model can perform better. Let's drop positive. Okay, so now the size is 3483. So we now have neutral and negative only. We do not have any positive sentiment. Now we have even more accuracy. It's 89.8%. So when we reduce 1 sentiment, we can see that model performs slightly better. Okay, so this is how we can perform the sentiment analysis using multinomial naivebayes. So that's the end of this video. Thanks for watching.